And then back here, this is the pivot pin that it pivots on, and I'd probably do something similar there. And then the boundary condition would be to fix both of those shafts, basically, and then start playing with loads, but how to characterize the loads. Just to interject that is what I do is model this and then put a shaft here and a shaft there, and then figure out how to push up on there, simulating the weight of the, but I don't know how you do that. But go ahead. I didn't mean to interrupt you.
Yeah. No worries. No worries on there. And yeah, and part of it, yeah, part of it goes down like, hey, can we model like here? I mean, in real life, hey, you're doing a full FEA. Hey, can I represent it as boundary conditions, or do I need to include more parts of it? It's kind of like the, I guess some of the discussions or things that sometimes go on that front. But I'll tell you what, we'll look at a couple things here. I'm going to open up, I guess, a couple of these parts here directly. Okay, let me go ahead and go to this guy. And yeah, we'll start one at a time on this guy. Okay, so got this one. We got this one as well. Okay. Alrighty, so I'm gonna go ahead and share my screen, and we'll take this kind of one at a time for what we're doing. Okay, and are you able to see my screen? I should have, I guess, one of the parts initially up right now.
I don't know. It looks like I've still got my solid. Okay, there you go. Now I see it.
Hey, perfect. Perfect. Yeah, so very first, just kind of, I guess, knock the first one out as far as, hey, being able to split that face, using a split line on here. I'll just really talk about that. So yeah, I only want to fix a little portion of here. Really what you do is, hey, you make a sketch on where you want that face to be split on there. So in this case, hey, let me like start a sketch on this face, and then I'll just draw like two lines just arbitrarily on here. So hey, I'm going to draw two lines just saying, hey, in between these lines, that's where I want the face split. Now, obviously, I just drew these randomly and on here. But then that main command is going to be the one called split line. So your split line command on there is that takes in a sketch and then it projects onto a face to split it. So I have here, hey, that split line command, but I click on that guy and I look over on my left and I have, hey, I want to project some sort of sketch. So I choose a sketch I want to project onto what face I want to split is what this one's doing on here. So I have my current sketch and I say, hey, I want to split this face. And then I hit my green check. And now we can see, hey, now I can select that face separately. So then I could, hey, apply any sort of boundary conditions or stuff on there. So that split line command is going to be your friend as far as, hey, yeah, as far as doing that portion of the aspect. You just draw the lines where you want it to kind of intersect where the part would be, and then that split line is what you'll use on that front.
Yeah.
So that'll be the first one. Now I'll go over here to our other part. Actually, yeah, let's go ahead and I think I opened it up as you're going along. Yeah. So we have this part here for what we're doing. So our other aspect, I'm going to look at it here. Okay, so we have our sheet metal, different components. Okay, so several different components here. Is it mainly, let's see. So I see a bunch of multi-bodies of what we're doing. Okay, so a lot of these, it looks like are our fillets, our fillet welds. It looks like on there with it for our different components. Okay. So what we can do, yeah, so we can look at this guy. So I'll have to evaluate to see what is what's going to be best, but especially if we are trying to be within the constraints of Sim Express, is that getting it to be a single part, so that we can be within that constraint on there, is going to be an aspect. Now, this combine command is going to be our friend, and I'll actually put it up here so we can see. So the combine command, what you can use it for is like, hey, you have multi-body parts, you have multiple on there. Then if they are touching, if they can be combined, then you just select, hey, this one part and the other part on there. And then after that, hey, just combines it into one solid body. After that, just from that one command. But they have to be touching. You have to it can't combine if, hey, if one part's off in space and the other one's
Yeah.
off in the other one. If I go and combine, and then just for the example here, if I choose this one, and then assuming these are touching, if I take one of my fillet beads and this guy, is that I add, and now those are now one body. So everything I've selected here is now one single body at this
For the
point.
sake of simplification of the model, it might be good to have either a configuration or a part where the weld beads aren't even in there, because they're not going to significantly impact the loading of it. But I see that the combine tool will be great if I can get it all to combine, but you can't combine combine two combines, right?
You could. Yeah, so as soon as you combine, it's going to be a separate list here in your like bodies folder, your cutlass folder. And so I mean, you
Yeah,
can combine anything from this list. So we see this one I just combined is called combine one down here now.
right.
And so now I could take that combine and combine it with anything else at that point. And so you definitely can. Now, you're absolutely right. It's evaluating, okay, how many bodies, what detail do you need for the analysis on there, especially within the Sim Express, or we aren't doing mesh control and things there. Hey, getting down into the detailed stress of the welds. Hey, probably not important, because hey, we are just kind of getting those ballpark results there to begin with. But let's take a look. So if we were just, so I'm trying to tell which ones are which here, but so we got a bunch of our weld beads. We have it on this. So I guess as far as the main bodies in this analysis, we have, I guess, our main sheet metal part here. Okay, main sheet metal part. We have a bunch of fillet welds. We have this plate that's on here. We have that plate that's on there. Okay. Is this one bent? And is this a separate plate over here, it looks like? Okay. So probably to simplify things, absolutely right that, hey, we'll add like an FEA configuration on this. And then we can say, hey, let's delete out maybe the bodies that don't matter. So
Right.
I mean, we could exclude them from the analysis if we're doing a full blown, but if I have this delete/keep body command, allows me just, hey, in my feature tree, let's delete the body. So it's still there if I suppress this feature. But at this point, hey, let's me kind of delete out bodies that maybe we don't care about for this analysis. So I go in this one, and there's two ways that I can delete them. I can say either delete the bodies that I select, or we can say only keep the bodies that I select. So if I say keep bodies, I'll say, hey, maybe I'll keep this
Yeah,
main one here.
yeah,
Maybe keep these guys.
yeah, that's simpler.
Probably like that.
Yeah,
And then it's going to
yeah.
delete out everything
There's
else.
a little brace down there in the bottom. Yep. And
Okay.
then there's two bars up at the front, on the inside, two little
Ooh,
blocks,
okay.
threaded blocks. Yeah, yeah,
We got those
perfect.
guys. So, hey, those are the ones saying keep. So now just, hey, deleted out everything on, oh, let's get on this one. So deleted out everything on that front.
Yep.
Now, if we assume in this case that this is a, um, yeah, I guess if we assume right now this is all just kind of one part, they all just kind of acting once together. Once it's welded up, it's just kind of acting as one. Is kind of our assumption here. Then it looks like, I mean, we'll have to see exactly if all these are touching things here, that we can use that combine command to go ahead, and I'll just see if I can select all of these guys, and I'll see if it will let us, if they're all touching, is that it will let us combine it. But let's see here. Okay, so there's something that's either not touching or an edge to edge on here, and so that's why it gave me an error saying like, hey, 0 thickness on this. But I can try this kind of one at a time and see what geometry modifications I need. So I can just try first off, hey, maybe just these two parts here. Let's see. Okay, so that one will let me combined. So I'm going to go ahead and edit it. Actually, I'll do another combine command just for the sake of showing you can do multiple in a row. So now combine, hey, I have this one body that I combine that's including that plate. Then, hey, I know this one, it for sure can combine. So that looks good. Maybe I'm going to try these two at the same time just to see what it does here. Okay, so these ones right now it's having problems with. So I'm just going to combine those. And so it looks like, I mean, it looks like it's touching or some aspects on there, but I'll take a look at that here in a second. I'm going to try to combine my other portions of the model. So I'll use my combine command again, and we got this body. And we'll test to see if these ones are able to be combined. Okay, yeah, and this one, it's not combining here. So we might have to do some geometry simplification, but I'm going to do kind of one at a time and see what it's going to do here. Okay, so it was able to do that one. So right now we've got a body that represents several on here. Okay, so we've got a number of them now we're down to 5 different, and I should be able to do another combine, I would expect, from this plate. Well, actually, is that the one I before? Let's see if that one. Okay, so right now we've got it down to 4 separate bodies at this point, and you see I've done like a bunch of combines just to like see what I can do and what I can't on there. So right now it's going to be everything is combined except for right now these two plates and our connector plate. So right now it's seeming to give a little bit of problem combining these. So let's see if we can determine why that is at this point here. So I'm going to look at this guy. Let's see, is there a little bit of gap? Okay, and that's why it's not combining right now. Hey, there's a little gap right here, so they're not touching. Yep. So that's why it's not letting us combine. And so in this case,
hey, can it edit that part and make it a little bit wider so it does combine?
Exactly. So hey, we could do things here. So it's a multi-body part. We could go back to the original one and change the geometry, or I could do some direct editing right now. So I say, hey, let me do a sketch on that face, and I just converted it, and then I'll extrude boss from here, and I'll go up to surface, just so that, hey, it just fills in that gap on there.
Nice.
Save this guy. And let me see, this one might have not combined. Let's see, is my merge results on? Okay, and I'm going to do merge results because I think that's going to allow it to merge these two kind of in one go like that. Okay, so that combined it. And just for the sake of our structural rigidity, we'll want to do the same thing over on this side here. So hey, we'll go into the sketch. I'll convert that, hit my C keys, my shortcut, and then I'll extrude this up to that surface. So up to surface, up to this one on here, and I'll have it merge it so it's all one body at this point. Okay, so now we are down to this part and these two. So we're down to 3 parts, and pretty soon it'll be one single part once we get it there. But now we kind of evaluate about why this one is not merging per se. And I can try one more time with my combine. So I can say, hey, and I don't think it's going to let us. It doesn't look like it. Okay, so I'm going to try and see if just the bottom one will. Okay, yeah, so both of these are having problem combining. Now, I'm going to see if I can do a cross-section view to maybe get a better idea about why it's not combining. So I'm going to look at my cross-section. Okay, and it looks like a similar thing. Hey, there's a little gap right between these on it here. That's causing it problems. Now, there's different ways that we could go about this as far as making it so it is touching. But let me see, because we could do a similar thing, but we want to touch on both sides. So I'm going to go ahead and measure to see how big. Okay, about 0.01 it looks like is that gap right there is what it's referencing. So multiple ways that we could do this. What I'm going to do is I'm going to use a direct editing technique, which allows me to kind of just like directly modify the size of this guy. Ooh, and actually, do I have, is it, we have a gap down there as well, or is it only in the top? Ooh, okay. So we want to make that a little bit bigger. But what I'm going to do is that there's a direct editing technique, and there's a command called move face. And what that does is that this move face command um, allows us to go in here and just say, hey, whatever the size of this is, like offset it by a certain amount, make it a little bit bigger of what it's doing without like going back to the original model, which we can go back to the original model, but in FEA especially where you're just trying to modify to get a good model that you can set up, then hey, this is a good one. So I'll go ahead and put in like maybe 0.02, which is going to be more than I actually want, but was going to be combined, so that's fine there. And if I can just be able to select that face, yeah, let me select tangent C to get that guy. Is that offset? We can kind of see the outline, but it's going to make that bigger in that case. And so I'll go ahead and confirm that guy. Then I will combine these in a second because now it's definitely intersecting my parts, so I can combine them into one piece. Then I'll do the same thing just so I can combine them all at one time. Hey, move face. And then I need to get one of my faces over here. Now I'll see if I can see it without doing a section view. Maybe I'll use my select other. Yeah, I'm going to get a section view in there just so I can see that face. Okay, move face, we'll get the same. I'll right click, select tangent C. Okay, that one's going to do the same thing of making it big. All right, so now I should be able to go in and combine again. And because they're intersecting, because it's on theirs, I'm expecting at least this point to be able to do this body and then these two, because now, hey, they don't have that gap. And yep, it's able to combine it. So now I look at my cut list folder and it is just one item, one on there. So right now this is one single part.
Excellent.
Right now with it. So just acting like, hey, one solid piece at this point. I'm gonna go ahead and save this guy just so we keep it up on there. But hey, we're a single part, so at least within our Sim Express yeah, I guess our Sim Express constraints or limitation there. Hey, we have a single part. We can't do it on that front. Now with that
Let me ask you a question about those parts where you did direct editing
Yep.
to extend them so they touch.
Yep.
They can either touch or they could be enlarged enough that they go into the other part, right? It's touching or being into the other part are kind of the same thing. It would result in a one solid body, one part.
Yeah, great question there. So as long as you combine those parts afterwards, then it's going to be the exact same thing if they're touching or if they're interfering with each other. Because even though it was like interfering with each other originally, once you combine it, it's like, hey, there's no interference. This is just one part. It's not two separate parts that interfere with each other.
And then as far as these parts are actually both the same part in SolidWorks. You know, they're modeled as separate, completely separate parts. But you did a you edit each of them separately within the assembly. How did that affect the part? If you go back and open the individual parts, they're still the same. They haven't got that feature because that feature's within this assembly now, right?
Yeah, so this multi-body part here, you're absolutely right. It's within here. So it's like I look at my order of operations and right now in my tree, hey, that make multi-body part, which like
Yep.
created this from the assembly, hey,
Right.
that one is still in its original state. Hey, we did all of our things here, but now it's kind of if I go back to that assembly where that's referenced from, hey, those parts are the same. Those have not changed at all at this
Right.
point. And then, but down here with the tree, hey, for my current configuration for FEA, I've done some modifications that's only purely here for the FEA, or this configuration, I should say, on that front. So, and usually that's going to be a relatively common workflow when doing FEAs. Like, hey, you create a new configuration of, hey, what sort of simplifications, what sort of changes do I have that, hey, um, that you can do for its analysis. But yeah, but this is probably at least how I would do it. Multiple ways to go about this, but this is how I would go about it.
Awesome. Yeah, so the modification that I made, which is cutting out this big window and seeing how much that reduced the weight and stuff,
Yep.
this model would kind of be about ready if we define the boundary condition of this being fixed and this being a load, and we could potentially just fix each of the pin uh, holes as one fixed point, and then maybe just load these as one fixed. We don't have to make a beam to go across these, because we could define this radius, this face here, and these pinholes, define them as fixed and define this as a load, and then see, because that's really all that's going on when the rider sits down or is loading this point here, and then so this is fixed and at some angle. Anyway, it looks like it's ready to be done, to use try to use Simulation Express on it.
Yeah. Yeah. No, I say that's fair on that front. Yeah, and then I mean when we say like, hey, these are fixed. I mean, if you made those fixed, I mean, whenever you're assuming something's fixed, you're assuming, hey, it's infinitely rigid, it can't move at all
Right.
on there, which I mean, hey, we're assuming, hey, whatever axle's on, we're gonna get no movement like left or right either. I should say actually, which I mean, we don't expect the loading to go that way, but you do fix it in that way as well. Um, so yeah, so multiple ways to go about this, but yeah, no, you're absolutely right on this front as far as from a Sim Express standpoint. Um, and let's see, it's I don't use Sim Express directly very often since I just use the full bone sim. So we'll
Right.
see if I can click through some of these with their interface. It's a little bit different here, but a lot of fixed geometry for what it's doing. So let's say, yeah, like you said,
Wait,
those
that would probably be our load, and then
okay,
we
yeah.
want to
So if the
fix the
load's
two
on there,
pinholes.
fixing these
And
guys.
yep, if we fix those, and the load is on the wheel going up.
Okay, so got that one. We want to make it a selected direction so that it goes directly up. And I'm assuming would it be as far as the direction goes on here? Would it be
Yeah, you could use one of those edges. One.
okay? Would it be like right up from
Yeah,
the
that'd
axial
be a
on
good
there?
starting approximation. You could do a split line rectangle there and adjust the angle, and that way you'd have a way to adjust the direction of the force. But for right now, I'm just curious if this is going to run. Any
Yeah,
edge is probably good. Yeah, that proximate edge there
yeah,
is good.
yeah. Let's see. And that's a good one. For some reason, it's giving me a little bit of struggle selecting that. So let me go ahead and just save this guy. Yeah, it's giving me a problem selecting any of these edges. So I don't think. Oh, interesting. So it looks like in um. Okay, so we got those guys. So it's not giving me an option to give it on there. Let me just make sure this isn't Sim Express.
You know,
specific
kind of, it
thing going
seems like
on
kind of
here.
maybe extruding the hub in there, adding the hub um, on might be the best way to define have one feature you can define the forces on.
Yeah, yeah, and that is fair. I'm just seeing here, yeah, with our edge, I'm going to try to do on here, which I mean, SimExpress should allow you to do select direction with, or I guess I'm assuming that lets you do selection without problem. But I'm going to test real quick on this part. Yeah, we'll go ahead and close this here for a second. Okay, and I'm just going to add in regular simulation just for the sake here of a second. Okay, yeah, so new study, got this guy. Yeah, so it is interesting. I'll have to see if that's an intentional limitation of SimExpress. But yeah, so I open up in one's on there, but giving me that selected direction, which I mean,
What
um,
about selecting this face down here as the direction?
yeah, and yeah, and in either one works, I guess, in regular sim for whatever reason, and it might be a limitation of SimExpress. It's odd that even gives the option still, but it's not letting me even do a selected direction in general. Where right now, hey, in Full Blown Split Sim, it is letting me do that, but got this guy on this one, and then just for our sake, okay, yeah, so it is letting us do the selected direction on here. Now I'm going to go back to this SimExpress study. And actually, let me unload the regular simulation on there. Let's see if I can turn back on our SimExpress. Okay, so got the fixtures. Yeah, so it's looking like it's SimExpress. Yeah, I mean, I'll have to check to see if it's intentional or not. But yeah, it's not letting us do selected direction. Just normal to the face. On there for what we're doing. Now, we can I look to see if that's intentional or not. Kind of later on this, but just for the sake of what we're looking at right now, hey, if I just apply this load, saying, hey, so I can get some faces that just goes normal. In that case, then this will get us kind of ballpark some of
Well,
them on here. We could model in.
I've used Simulation Express a lot in the past, and kind of hacked around. A lot of times I'll just put some feature in there that's like a giant block that I know can't flex, and then weld it to the part and as a part of the part, and then use features on it to control the direction of the loading. So if you extruded a giant hub, like a 2-inch diameter hub between those two forks on either side, and then made a face on that big flat, cylinder that you put on there, then it allows you to load the face on the cylinder and control the direction of the force, because, basically it's like those two sides are joined together. Anyway, yeah, I can see that there's be ways to get it what we want by the
Yeah.
limitations that are within Simulation Express that you're showing me.
Yeah, absolutely. So yeah, so different ways to get around that. Get around that workaround, or I guess yeah, get around it on here now, just to kind of see some of the results here in general. Okay, so got 500, got it on there. As far as material, I'm assuming some sort of steel, or is it aluminum on this
Aluminum,
guy?
it's 60,
Okay.
61.
Okay, perfect.
6061, the SS 6061 T6 probably. Right. That SS is funny. You know, where they put the SS behind it, that means that it's good for doing analysis. But so many times I've used that and it goes on the drawing, and the machinist looks at the drawing and he goes, "Oh, it's stainless steel." And then he just starts making
Uh,
the part. It's so funny.
oh,
But
that is funny.
that's a just sort of a funny thing.
Yeah, and the SS on there as well, yeah, is some of your stress strain curves. So if you're
Right,
doing like
right.
more in depth,
But I can't tell you how many times I've had some parts and I'm looking at them and I'm going like, why is this
stainless
stainless
steel.
steel? It's supposed to be aluminum. And you go to the machinist and he goes, "Oh, it says stainless steel right here." And I go, "Did you read the whole thing, bozo?"
Yeah. Oh, that is funny. That is funny on there. Yeah, and yeah, because typically if you're running like deeper analysis for nonlinear where you like care about results after it starts like permanently deforming, hey, you need like a full stress strain curve of like how it
Yep,
represents it after it starts on there. So those are ones saying like, hey, these ones have that,
right.
but but obviously it confuses things for sure on that. But yeah, but let's go ahead and see. I mean, I expect us to get at least some sort of results. Now, I said we don't have any sorts of mesh controls or things on here, but we should at least be able to see see some results for
Oh, look at that. Yeah, it wants the two sides to be tied together because it's flexing, it's letting it
yep,
flex out. Yeah, that's funny. That's
yeah.
funny.
So in
Well, that's
that case,
cool.
hey, if our axle, yeah, so getting it on there, flexing out like you said. So at
Well, really
least that's
cool. I
on.
mean, this is, I've gotten my money's worth right here for the free session. I'll tell you what, because I can play with this for a long time.
Yeah, yeah, no, absolutely. Absolutely on that front and kind
That's
of hey
great.
changing
You know how it
changing
is
the
iteration wise. You start, you can design the thing any way you want it. And then you do the stress analysis, and then and then the whole iteration loop is just an endless process, like, well, what about this? What about this? Very
yeah,
cool. So
yeah, no, absolutely.
what you've done right here, once I tie those two sides together and put the load on the hub, which we might have time to do, um, then we can experiment with the cutouts. I've got that huge window in there now, but
Yep.
one thing Martin was doing is he's remodeling it. That sheet metal is 3 millimeters thick right now, and he has an idea where he wants to make the sheet metal 2 millimeters thick, which will cut up basically a third of the weight right away. But with this model we have right now, converting that thickness of that sheet metal to 2 millimeters would require making a that would require a lot of work. We can't just do that easily to this part.
Yeah, and I guess converting the main one to 2 millimeters, kind of have to look to see how it's modeled up. I mean, questions like that, like how thin can I make this and things there, I mean, would be relatively common simulation things that you'll set up on that front. Like I don't know if you've done like design studies before or familiar um with what those are, but those are basically saying, hey, I set up one simulation, now run a bunch of different
Right,
iterations of different geometries and so
the
forth on there.
optimization feature.
Yep.
I've used
Yep.
the optimization feature some, but again, I'm always stuck. I'm always just using parts that I've modeled, and I'm not sure I could redo what you've done here without. If I went in, what I have to do is go back to the assembly that the multi-body part is designed from, and make a new assembly and change the thickness of that sheet metal and tweak all that stuff. Um,
Yeah. Let's take a look here. I mean, just for our sake of what we're doing. So I'm going to open up our original because I make mold body part command on there is linked to the main assembly. So it looks like it's updating the cut list right now. I'm going to go ahead and save this. Okay. So it's done a multi-body part from that guy. Okay. That's what it's done. But yeah, we'll go back on some of these guys here. Yeah, so it's rebuilding. So I'm going to edit that in context. Okay, so here's the original assembly where this one is at right now. And it looks like a different configuration on here, but if I go into just this part, okay, and then this one is with my different one on here. Yeah, so I mean, I'll see if we can get it to propagate as it goes
Wait a
on here.
second, that's a surprise to me. I thought those were two separate parts. They're cut apart somewhere. There's a weld down the middle, but I guess that doesn't matter. I guess there's a cut feature in the assembly where oh no, there's the split. So it's welded there. Yeah, so it's welded together there. I was looking at that top surface and looking for so that is
Yeah,
one
look for the
piece of
seam.
sheet metal.
Yeah, so this is one piece right now. So I can see, so I'm assuming this is the one that's 3 millimeters, you said right
Yep.
now, or it looks like about 3.5 millimeters.
Well, yeah, that's what I measured.
Yeah. So let's see. I mean, just for the sake of what we're doing, hey, I bring it down by 1 millimeter right now. So hey, now it's 2.5. Is that now that should propagate things, and I could have done that in like a separate configuration I pull forward, but hey, I go 2.5 millimeters, and I go back to my assembly, and let me just make sure it's the right configuration that it's done it. Yep, that one's 2.5 millimeters on there, and if I go back to my multi-body part, so that should be
I thought
um
that was a one-way deal.
that make that make multi-body part, which is a new command 2024 on there. That one's parametric, so that one's going to update
Nice.
and link back to the model with it there, which is a great one. It used to be, hey, if you save it out as a part
Yeah,
um on it there, then hey, they're now no longer linked. They're separate on there. But yeah, with
right.
that official make multi-body part command that came out in 2024, it makes so it is referenced on that front. Now we'll take a look on here. Okay, and I'll just make sure that this one is the 2.5. Let's see, and it looks like it's um in metric right now. So I'm just gonna go ahead and change this just so we can see. Okay, yep. So it is 2.5 on here. It looks like the only error for when it's combining is hey, one of the Phillip beads had some have some problems once we modified the thickness, but it seems like everything else is set on here. So now it's that same model, but 2.5 millimeters thickness. I can measure that just to make sure. Yep, so that one is that 2.5 on there. And so this is going to be my same analysis before. So if I go back into my Sim Express, is that hey, now it's changed. So we could go in and let's see if we can rerun this analysis. So now hey, it's already has what we need set up. Okay, and this time meshing failed on it. I'm gonna take a look. Now, one thing to note is that typically in FEA analysis in general, when you have thin components, you're treating them as what's referred to as shell elements, which means, hey, you represent it as a surface with an assigned thickness behind the scenes. And the reason for that is that to really get good results on on thin geometry on like sheet metal like components and things there is that normally you need at least two elements going through the thickness of these parts on there. And so what shell elements do is allows you to get around that to hey represent this as a surface on there with it. And so I'm guessing with some of these default settings on this is that it's um yeah, it's having some problems, but let's see if it can even get it to mesh. And it might be too thin for it to get some of these elements in here, but let's give it a try and see. I'm going to save this guy. Okay, so got those, got these. Okay. Yeah, seems like having some problems on that front. Okay. I think it's running something right now. Let's see what it's got. Yeah, it seems like Sim Express for a second is having a few problems, but let's try. Okay, that seems to be locking up. Okay, so I'm going to try do a couple things. Let's see if I can get out of here. Okay, so got this guy. Now I'm just going to take a look here and see if I can troubleshoot some of the failing meshing on this aspect. Um, on this, yeah, because it went thinner. It looks like that's when it tried to fail to mesh on that one. So let's go ahead and yeah, I'll activate my FEA configuration here. That should be fair. But yeah, but for the most part, we'll see about it seems like when it got thinner, that's when it fell to mesh. But we'll go ahead and take a look and see if we can find out in this case. Okay, yep, so it failed on this one, somewhere on this. So I'm just going to try to reduce my mesh size, or I guess make it more dense. Okay, so somewhere in there. It's getting too thin. I'm going to make sure there's no like sliver faces or things that may be causing problems. Okay, got that guy, got that guy. These ones are all combined. Okay, that could reference it, but no, that looks at least decent. But usually if it fails to mesh, there's some sort of small small feature that's referencing on here. But I'm going to let's get this to be a curvature based mesh and we'll see if that gets us by.
All right.
Yeah, so this one, I mean, I had to go into full sim to change my mesh controls on it here, just because hey, it's so small. But yeah, that's going to be the root of it. Hey, I look at these mesh elements that are on here, and this is when I made it about it looks like about 5 or 6 times denser than what that kind of initial one was. As I see these
You know,
elements that
those two surfaces right there are actually joined by a weld for the sake of what you'd want to do is make those combined or make them overlap or
yeah
touch,
make them
ideally.
combine on there. Yeah, no, I would agree on that front, and then at least for our ballpark initially, hey, some of these stabilizers at least connects those two parts since we're saying those are acting as one piece on there. But yeah, no, I would agree, but yeah, it looks like okay, yeah, some of these is going on in there. That's where it's referencing, but right now we got the parse, and we can see if I can get that mesh to change. Because I had to.
That little cut right there is in there so that they can put a plug weld in there to hold that nut plate in. That's why
Yeah,
that cut is there.
yeah,
Anyway,
no,
doesn't
that
matter.
absolutely makes sense on that front. Hey, having that little bit of weld gap of putting it in on that front. But yeah, so we got that guy. Now the main question would be, because I had to go into a simulation directly in order to
Right,
reduce this mesh density on here.
right.
Now, even with that being said, I mean, I might even try to see if I can look at some high level results here to see the difference. But typically, your rule of thumb, just in general, is that hey, if you're modeling these as solid elements, you want at least two elements going through like the thickness of these parts. And right now, it looks like hey, there's one a little bit distorted. So I mean, some of your bending lows and things like theirs that hey, those results would be yeah, the thinner it is, the more off it would be without having two elements through the thickness on there. But
Wait a second. You're saying there's something problem with the mesh as far as
well, typically,
working right?
it's more of a limitation of Sim Express, I should
Yeah.
say on this. So it typically, and actually, what I'm gonna do is I'm curious to see what we can get. So just for the sake of um of what we're doing here, I'm gonna open up just this one sheet metal part directly just so we can do some comparisons. But okay, got this guy. I'm going to say, hey, we have a um, FEA configuration on this front. That looks fair. But then if I go in, and yeah, I can combine those. Yeah, just for the sake of what I'm doing here, I think I'll combine them just to give that stiffness, um, give it that stiffness that
You can take out those
roughly.
plug weld holes too. Those could just be suppressed. Those holes that do the plug weld if they complicate things at all.
Okay. Yeah, I'll see if this is simple enough right here just to convert those three faces. And then I can do up to surface and combine them. And I think that should get all three of these. Okay, so that
Yeah.
does combine it in one front. Okay, so that combines it. So right now, I'm gonna go ahead and save this one. So I'm going to do two comparisons right now of this part. So I'm going to do a Sim Express originally on here. Okay, so we got this guy. So um just for the sake of what we're looking at here, I'm just going to say um just for an apples to apples comparison, hey, let's say that's fixed on this, and then to keep it same as our other one, let's go ahead and just get this guy 500. Actually, yeah, let's do 1,000, but have it be a total amount. Okay, so got that guy.
It'd be better if you fix this end
Fix the other end on there, and
because that's where the load is really for the rider, the weight of the rider.
hey, that's fair. We'll do it here, but right
Yep.
now, I'm curious. Got material, and sure, I'll make it the same 60, 61, T6 on this one. Okay, yeah, so our mesh density, we'll see if it lets us mesh in a circumstance, but okay, and it looks like it will let us mesh. Okay, yeah, so on here, I guess the main thing to note with here is increase that mesh density. So I look right now and say, okay, what's my max von Mises stress on here? And I see, okay, about 179 at megapascals is what it's showing right here. It looks like somewhere in this area. But the one thing to know with our mesh convergence and mesh density, especially, and this is going to be especially true with thin components on here, so I think it's worth this looking at on this front, is if I go back in and I change this mesh density now, hey, I'll change it to be a thinner value on this front. I'm going to change that guy. And now, if I run this one where before was about 179 megapascals, is that it will take longer, but I'm going to expect. Okay, and so this one, it went up about, it looks like about 15, yeah, about 15%, about 10% increase in there. So not, I guess, somewhat, but hey, our true values are probably closer right now. It's a 192 megapascals because we increased our mesh density. But as a rule of thumb, is that generally for the mesh density for your thin components, yeah, you'll want about 2 elements. So if we go in here and I guess it was like the 2.5 millimeters, is that you would want that mesh density really to have relative confidence in your results to be about half of 2.5. So, I mean, that would be pretty dense on there, but that's your general rule of thumb on there. But just saying, hey, as we increase that mesh density, then your actual results are going to.
As far as specifying the loading there, there's no way to make those as if they're tied, as if they can't, as if they're welded together, the two forces, because it's not representative of what you'd really see once you had the axle in there. You can't, the way the fixed side is, if you put multiple surfaces for the fixed side, they're all welded together and they don't move relative to each other at all. So, yeah, one interesting thing you could do is swap those, but is there a way without putting the artificial cylinder in there that represents the hub to cause those two force vectors to be so they're tied together?
So like they're tied together. So hey, just like kind of one like one load that's like kind of distributed over all four, or I guess
Right. So they
over both
can't
axles.
move those two surfaces, those four surfaces, as it were, can't move relative to each other. Because right now, the way it's doing the split, it wouldn't do that with the axle in there, obviously, the hub of the wheel. So when you
Yeah,
define
so
that load,
yeah, so you have a couple ways to go about that. In Sim Express, the Sim Express short answer is no. On there with it, I guess in Sim Express, yeah, the only way would be to say, hey, let's yeah, like I said, model something in physically to kind of keep these in line of what you would do in that circumstance. But if we were, let's see if I can do this guy. Let me go. Yeah, let's close out of this guy. Sure. Let me go back and do full blown sim. Yeah, so in full blown simulation, that on here is that there's a couple different ways that you could go about it. One is that you could add, hey, let me just do a more unique fixture. So instead of saying, hey, this whole thing is fixed, or I guess the whole thing on there is that you can just add an advanced fixture, which means, hey, if I set these hubs, both of these here, so they have 0 translation, but only in one direction. So I say, hey, both of these are fixed, but only this one, so they can still move, hey, up and down, left and right, and so forth, but they just can't move forward and back. Is that now that's a more conservative fixture saying, hey, right now those ones are not going to be moving relative to each other. They're not going to be moving on that front. Now your other option, which may be a more eloquent way to go about it in full sim, would be with a pin connection which it's a virtual pin on it here. So I could say, hey, take these two cylinders, what you're doing, and then you say, hey, there is no translation relative to these two. And so, hey, it's kind of like a pin keeps them in line. So, hey, those two distances, they're always going to stay the same. And so I could give it some sort of stiffness, but we're saying no translation on here. And so now with that pin, is that this is kind of a virtual representation of that keeps them. So, hey, can't move left and right on there. And then, hey, you could add your other forces, whether it's directly on that connector, which I'm going to go ahead and hide it here for a second on here. But just to show, if I do kind of that same setup as before of saying that guy, and then I'll do my lows, and just to keep it the same as before, I'll do these ones, but I easily could do that that face. Let's do a total. Oh, that is interesting, since those faces are slightly different sizes on the two sides. That's not going to distribute evenly. So I might want to do those as separate, but just for the sake to keep it the same, is that now I go ahead and run the study, we'll see how these results change because of that pin connector, where in reality, hey, this is pretty much the same as before, other than that pin. But now I see, hey, both of them moved in one direction, but they all stayed the same. So now I animate this, and you see, hey, those two are now staying together, but it's just bending off to the one side. In this case, but we can see that pin is keeping them relative distance, keeping them stopping from translating, like you would with an axle, or I guess represented by an axle on that front.
That's interesting, but it's because the surfaces that you picked are not symmetrical. They're not equal on each side.
Yeah, so if I want to change this now, so now that I'm in actual full sim, I'm just going to use these ones directly and give it a selected direction. That's going to be, hey, I'll just do it up from here. And now, since those ones are the same size on here, is that now I would expect it to be much more symmetric. I mean, maybe once it's exaggerated, it's going to be to one side. I mean, but the parts pretty close to being symmetric. We see some of those holes, see them on here. But now I click on this guy, and we see, okay, now here's my loading right now. Now that is symmetric loading. Now this is exaggerated by 85 times. It looks like my deformation scale, but we see, okay, now those distances are kept the same distance apart. So those kind of stay together as far as that goes, but now my loading is on that there. So, and I guess that brings up something just to be careful of setting up these loads, is that whenever you have your loading set up on here and you're selecting multiple faces, is that you have a few options over here in your tree. So right now I set up, hey, 1,000 newtons, saying total across those two faces. So I'm saying, hey, evenly distribute that 1,000 newtons between these two faces. Now, if those faces are the exact same size, it's going to have 500 on one and 500 on the other. But if it was saying like, hey, one is significantly bigger than the other, then it's going to distribute them based on area. So one would be a lot more load than the other. So you just have to be intentional about your setup in that circumstance if you're having different size loads and you're meaning for it to be a total load, just so that you represent what it is in real life there.
Yep.
But yeah, but I mean, obviously a little bit of tangent, but yeah, just with the question of keeping those tied in with how the axles, that that pin connector in full sim would be the way how you typically go about that, and in that circumstance. And then I guess going along the same lines, one other way that you go about the loading, because hey, in real life, hey, that load is kind of distributed over those two faces and so forth on there, is that what you can do is, yeah, actually, let me hide this plot here, is that you could create some sort of coordinate system from, let's see where that one is. Okay. Yeah, so just for the sake of showing here is that if I was saying my loading, I want to get it, yeah, maybe here in the middle, is that I have what's referred to as a distributed load. So if I make, I'll actually just kind of do the setup on this guy. So if I say, hey, this point here, sure, let's get it. So let's get my Z lined up there. Okay. Okay, so in full simulation, what you can do is that you have this more unique load. It's called remote load / mass on there. And so what that does is say, hey, let me get this loading, but here like at a certain distance away. So this is how you would set up like, hey, maybe the loading's like on the axial in the middle, and that's kind of just distributed over those faces, or with your setup that you had before with the with the pedals that you had there, saying like, hey, let me get, I know I have a force on these pedals that's like transferring the load directly into here. Is that what this does is I say, hey, remote load / mass, and I can apply the load to these two faces, but I can say apply the load at this coordinate system. Let me make sure I get the right one there. Yeah, so apply it at that coordinate system. Then I can say, hey, do my Z. Let's say it's 1,000 total. Reverse it. Actually, let me get these guys. Oh, because of sheet metal, let me just for the sake of what we're doing here, suppress this guy. Is that this remote load here, you can see, so you can kind of see how this just applied it on this circumstance. So it's saying like, hey, it's connected to, oh, and I think I have an extra edge in there as well, but that's fine. Yeah, no, just have the one, that's good. But it connects those faces right there, saying like, hey, these are connected faces, but apply a load there in the middle. So we see how it's like, hey, virtually connected, but now, hey, that load is there in the middle. And so we get the applicable, I guess, torques and things here of applying a load there where that coordinate system is. And you do a similar thing if, hey, applying a load out in space. So like in the training class, for example, one example that we'll do with this guy is, let me go into sim. Let's see, I think in lesson 4 we look at it. No, it's going to be lesson 5. Yeah, so in the class, kind of going by to the handle, I kind of the handle setup. So we do a similar remote load. And so right now this is a joint. So hey, you have a handle. Let me get the full guy, not the simplified. We have a full handle that you're rotating in real life on this, is saying, hey, I apply some load on this handle going in on here. So I could be as similar as, hey, what you're thinking of as a pedal on there. But how it's represented in full sim is saying, hey, we don't care about all the stresses in this handle and everything on here. We just want to get the effects of that. So then in your simulation is that you set up that same remote load. So I think there saying like, hey, my load's connected to this face, but then you apply that load out on space. So I see over here, hey, that's where it's, so I get the applicable torques and loads, but it's connected to that face. So you get the, I guess, the loading effects on it there. But without modeling it in physically, that's kind of how it's typically done on that circumstance.
So I guess you teach a class in the full Cosmos Sim.
Yeah. So teach a class in the full full sim on there. So I mean, it's focused on your linear static studies on there too, which is, I mean, your main type, but it's going to be like, yeah, three days kind of going through, hey, all the different aspects from, I mean, mesh convergence to these connectors
Right.
to getting good results and things on there. But that's that's the main ones on that front. But
Well, I
yeah,
can see, I've used Sim Express a lot, and basically Sim Express is not much worth much. It's basically kind of good as a bean calculator, basically.
yeah, I mean for different things it can be I mean it can be good. Like I said, it's kind of like that sampler of single parse things on there. But hey, once you get into more serious, I mean it's I mean there's a reason it's kind of included with every SolidWorks license things there. It's like, hey, kind of the kind of sampler, kind of that base level on
You
there.
don't know what the cost is to get a subscription for Cosmos for 3 months. Do you know what it costs?
Um, uh, I'm trying to remember right off. If you're just looking at linear static studies, which is like, hey, I mean, your main study type, you're not looking at some of your higher level ones because there's ones like, hey, frequency analysis of things that are attached to things that vibrate. You have like different failure modes. You have thermal analysis or like buckling analysis, where it's like, hey, long, slender components under compression. It's like, hey, there's different levels of simulation once you get on there, but your base level of saying, hey, let me get the full blown package, but with your linear static on there is that um, I'll ask the salespeople exactly what it is now on there, but I can send a follow up email, just kind of what it is, just
Okay.
do on there. But I'm assuming, yeah, because got the 3 month on there, so I'll make a note just to get you the number on there. Now
Do they
the
rent? Do you do contracts consulting work through MLC CAD? You personally for doing these analysis?
Yeah, so I guess we do one of two. I guess we go about a few different ways on there. Now, at MLC, they've decided, as kind of like business in general, hey, we're not doing where somebody just, hey, brings in a project, we do it from start to finish and just present the results on there. Is that our purpose at MLC is enabling people to have confidence and run those simulations themselves. So with that being said, is that often what we do is that we'll say, hey, you have a simulation, have it on there. We can go one of two different routes. One is, hey, you get the software and we give you a base level training. It's going to be applicable for a lot of different things on there. Or we can do a more workflow development where, hey, we work with you and we kind of tell you, hey, here's all the clicks that you would need for the simulation to set it up and to get those results on your own. But you still have ownership of that, I guess, of that product at the end of the day on there. We just kind of show you and teach the process on it
Right.
there. Um, with
Well,
there, but
I think that that we might be kind of done with this as far as um I don't know, what to think because I'm basically not smart enough to do a lot of this stuff. I struggle, I'm 70 and I've lost if any edge I ever had. Sometimes I flummox around with SolidWorks as if I'm a newbie. As you know, things deteriorate as you get older. Um, but so I don't think there's any chance that I could, if I had the full Simulation Express, even with a lot of help, I would just basically need somebody like you to do it for me. But I wish we had recorded this. This hasn't been recorded or anything, has it?
I'd say about 5 or 10 minutes into our conversation, I hit record on there. So so we should have a recording of this.
Awesome. Yeah, because
Yep.
Martin will be very interested in this. It'll mean more to him because, this is his baby. And so that'll be great. So, but as far as getting significant answers, the things he can do with that box is he wants to experiment with the sheet metal thickness and then with the cutouts. And I think if I can get copies of the model that pack, if you pack and go it back to me um, with the simulation results in Simulation Express they'll be included in the model if you leave it that way, right?
Yeah, it should be included, and I believe that's the same with Sim Express. With I mean, with regular Sim, it's absolutely it's just kind of there as a part of it. But I think that's the same with Sim Express, and I'll see if I can double check to
Okay.
make sure that is there.
Yeah, but I think
Um,
if we spend any more time on this, I'm just going to be deeper in the hole of, oh, that's neat, but I'm a sort of a pedestrian relative to being able to do any of this stuff myself. Because, like I said, I've spent a lot of time at the request of. I worked at a robotics company at Georgia Tech for a while, and I used to come up with
okay,
these models. And people see the pretty models with all the colored force or stress analysis or displacement analysis, and they immediately think that you know how to do FEA just because you can make the pretty pictures. But
yeah,
the pretty pictures don't really do much as far as representing real world reality. And
exactly.
if Martin wanted to take, he could either kill a part by making these cuts in it, or he can make a brand new part by making it out of sheet metal and then sit on the trike. And it's like one of the Cosmos experts one time when I was over there at y'all's place and on Spectrum Drive, I said, should just regular mechanical designers like me, be using FEA? And he said, sure, as long as you keep your empirical data and your analysis data, as long as you sync those up somehow. Well, that involves both the model iteration and the physical product simulate to be, updated. And in a case like this, it's really expensive to cut up a part or make a whole new part with a different sheet metal thickness and to trust the model. Anyway,
Yeah. Yeah, no,
so that,
absolutely. I absolutely agree on there. And no, like I said with that iterative process on there is that, hey, I mean, having your simulation kind of built into the CAD just makes it so wonderful of setting up. So like even in this one analysis that I had over here, yeah, let me get it back to what that original one was on this one. Yeah, so on this original one, um, if I was trying to do because it's linked to the CAD, hey, let me see what it's going to be in 10 different thicknesses or whatever on here. I could do this design study and I could set up different variables. So I could say, hey,
wow,
let me add a
nice.
simulation parameter so I can choose
Yeah,
any of my CAD dimensions that are on here. So, I mean, I could try to find wherever that
the
sheet metal
thickness
thickness
parameter.
is there. But any of these
What is
dimensions,
it? 2.5 right now.
yeah, it should be 2.5. And it's somewhere. I can try to find it, or I can, let's see, is this, there's a 2.5. Okay, but yeah, so there's a few on there, but you can basically link it up to any of the dimensions, and I can see if I can find on there. But just for the sake, hey, I mean, you could do any of these. If I was just trying to say, hey, what's the size of the sheet metal, and I pull in like this random um yeah, that random length on here, I can say, hey, do that height, and you can do for any of your dimensions or multiple all at once in there, saying like, hey, automatically run it with, I mean, you could give it values saying, hey, run it at 12 different values or give it some sort of range on there. And then it just automatically runs through 10 simulations or however many on there. And then you kind of evaluate the design. So it's pretty cool being able to do more of your design aspects. Hey, once you get your main simulation on there. But yeah, but with that being said, yeah, like I said, I'll talk to the salesperson just to get the number of currently what it is for a 3 month on there. I mean,
Okay.
if you or whoever using it on there does get it, is that, I mean, absolutely would say, hey, the training with it, which we have it either as like, hey, here in our office, which I mean, in our office here in Georgia, I mean, it's we have it usually twice a year, which the next one is next week that I'm teaching on that one. But then several times throughout the year, we have an online, where it's kind of a similar format as what we're doing right now. Other than, hey, I have screen sharing sessions where I see your screens at the same time I'm working on here, so we can kind of go back and forth. But um, as a part of it, you just say, hey, here's the 3 month, here's what the kind of the training would be, just so you can, because it's one thing, like you said, to have the software, a whole nother thing, hey, to have
Yeah,
confidence in the results. Classic FEA saying garbage in equals garbage out. Essentially, for just because you have a pretty picture doesn't mean that it's
right.
necessarily
Yeah.
correct on that front there. But yeah, no, I think sounds fair. Because I mean it's yeah, simulation is incredible, and there's a lot of good applications out there. So that is
Okay. Well,
fair.
good. Well, we'll see how what we can do along those lines. You know, it's interesting with Inventor. He's got an old copy of Inventor, and I was forced to use Inventor for a few years in my career
Um,
as a full-time mechanical design engineer. And you know, Inventor is okay, but it's not SolidWorks. It's like SolidWorks is just so much better, especially support wise. And you know, Inventor, they just kind of hang you out there to dry. And I've never really understood why they do that, but they don't have really value added resellers like MLC CAD that I know of. It's just like you're hung out to dry, and it's like just go out on the internet and see if you can find somebody in a chat room that can help you. And I've just always loved SolidWorks for that hold my hand sort of thing that y'all do. And so if we got a little bit of time left, I had another question
yeah,
on a
of
completely
course, of
different
course.
subject. And that is, I always struggle with configurations in assemblies. So in
Okay.
configuration in parts is pretty easy and nice, but configuration, the difference in configurations between suppressing a feature and making a feature visible, you can do both. So if you have a part, you have a part configuration, you can hide things or you can suppress things. And the relative difference between those and uh, but then in assemblies, I quit using assembly configurations entirely because the way it suppresses mates is extremely frustrating to me. If you suppress a part, it'll suppress all the mates of that part or
Yep.
subassembly. And at
Yeah,
that
all the
point,
ones that are related.
my model is toast. My model is like, especially if I have any in-context features, suddenly I've touched something and move it, and I go, why is that moving? I wanted to suppress the parts, but I don't want the part to move now. So I
Yeah.
don't know.
Yeah, I mean, I guess I have a couple initial, I guess, thoughts on there. Now, one thing is going to be evaluating if you need different configurations or if you can go different display states is what's on there. So configuration is really when you're doing any changes on your parts that would like technically change the mass or something of your model. Like, hey, I'm changing a dimension. I'm changing maybe the configuration of which parts are on there. Like maybe this part is completely removed on that. So that's one aspect of saying like, hey, you have configurations. Now display states is hey, saved out views of stuff that is purely visual. So hey, I'm hiding a part, not suppressing, I'm hiding it. I'm changing the color, changing anything on there. Is that display states can be nice. So like I go into my configuration tab on this part here and I see, hey, my configurations up here, but then down the bottom I have these display states, which looks like there's a few down there. But
Hmm.
display states are nice for saying like, hey, I still have all my parts and maybe all the mates that are related to here, but if I just hide them, then I can and go through. So like if I don't know if I add a new display states that um have on here that maybe it's saying, hey, like no, I don't know, I can do a couple things on that. But yeah, maybe this one's gonna be, hey, like my no chair configuration or my no chair display states like, hey, if I hide the chair, is that now it's only this configuration or this display state, I should say, that's hidden. So even though it exists and all the mates are still there, so it doesn't break anything, hey, I can toggle between these down at the bottom. And so, hey, I go back to display state one and I see, oh, the chair is there. And then I toggle between my other display state, which I could um, name no chair, whatever, and I see it's there. So it kind of saves it out if you're purely looking for visual aspects on
Yeah.
there. Now, if you actually do need I guess, parts to be, I guess, excluded. Like, hey, in this configuration, this part doesn't exist on there, then hey, you're probably going to break some mates. I guess break some references that you'll need to fix on there. Um, because hey, if there's kind of a, like you said, in context or different things that are kind of dependent on that part, like hey, if that part doesn't exist, yeah, it's going to break things. So you might need to fix stuff or see, hey, can I model this in a different way that don't need the in context? But with that being said, um, just hiding them and being careful um, might be fair on that
Yeah.
circumstance. The other aspect um, that I'll mention is that if you want the part kind of there but not be included like in a bill of materials, because that would be really the main concern that I think about. Like, hey, we hide it, or like we still have it there for kind of our references for our in context, but this part doesn't exist, so we don't want this to show up in our bill of materials. Is that any part of here that you don't want to show up? Like I could say like, hey, like this this part right here, you could right click it, and then there's this properties section on here, and I can say, hey, for this part in this configuration, exclude this part from the bill of materials. So then, hey, it
Yeah.
doesn't show up in the list. And so
Right.
that's a way where you could just say, hey, it still exists, just hidden or whatever on there, but this exclude it from the bomb there. So
Yeah, I
that'd
saw
be
I
kind of
had a
my,
hide component button there too.
yeah,
Okay.
able to hide it. And one little I guess this is kind of a side note, but one little shortcut that I'll use all the time to kind of hide and show components quickly is that instead of having to, hey, right click hide or find them in the tree and right click hide or show, is that I don't know if you used this before, but if you hover over any component and if you hit your tab key on your keyboard, is that hides that component
Oh,
just on there, so you can like quickly go, hey, hide on there. And then the
so
cool
you're
thing about
holding down the tab button?
Yep. So I'm just hitting the tab button as soon as my mouse cursor is over a part and it hides it. But then if my mouse cursor is over where that like part would be if it was visible, then if I hold down shift and hit tab again, so that's going to show those components um as you go along on there. So that can be a quick way hide and show different things on there. But yeah, that's a shortcut that I'll use all the time.
Yeah, so it's going on 10 years since I was used to sit in a room at Georgia Tech with three other guys who were all running SolidWorks. And
Yep.
that really ups your game having everybody, together doing things. But
Oh,
anyway,
absolutely.
yep.
Absolutely. No,
Well,
I
for our 2025 2-hour session, I'm probably gonna just ask for somebody to come and help me do the dumb stuff that there's a lot of stuff. When I first started using SolidWorks in 1995, they were shipping me a new set of CDs about every other day because
uh-huh.
it was so buggy. It was basically
uh-huh.
a alpha release
Yep.
anyway.
Yep. Yeah,
But I
no, it's
haven't kept up. It's gotten too much, what it can do.
yeah. Yeah, no, absolutely. And there's obviously a lot of new things, but at the end of the day, hey, which new things are going to be applicable to what's like important to your workflows or what you're modeling on there? Like, hey, for you, I saw, yeah, that your one part that make multi-body part from assembly on there. Hey, that's a new 2024 feature that makes it great. So hey, like you said, like, oh, we have a connection back to the back to assembly we have there. It's like,
Right.
yeah,
Yeah.
hey, we have that now on there. But like you said, hey, depends the workflow, depends what they do on there. I will say, as far as what's new, is that in addition, like on our YouTube channel, things there, we have videos that just kind of, hey, here's a quick overview of, hey, some of the new aspects of different parts of the software, whether if it's simulation, whether if it's just your main part modeling, assemblies, or whatever aspect. But we do have videos that I at least for awareness, saying like, hey, what's there, because half of it is just knowing what's new to see if it'd be applicable for you or not, kind of thing there.
Well, then you're offering Solid Professor starting last year. That was a game
Yeah.
changer for me because I always log in and go on YouTube and end up watching some guy from India tell me how to do
Yeah.
something, and I can't understand them, and it's not a good explanation. Solid Professor is so well organized and everything.
Oh, I
I
agree.
love a Solid Professor.
Yeah, no, that partnership they have with them, I'm the same boat. Just so glad. Really, it's just helping more people succeed. Using SolidWorks on there, like I said, having those quick, just high quality videos and quick topics on there. It's yeah, no, I'm with you. It's fantastic. It's fantastic. I'm glad we're able to offer it,
Yeah.
um, offer it to people. Awesome. Yeah. What other questions you got on there too? I'm here to help. I'm here. So
Um, well, and the other question I have is that about backing up things, I guess, and using cloud services. You know, I use Dropbox now to back things up, and I ca- back things up on hard disk. I tried using OneDrive, which I have the subscription for Microsoft 365, and that
yep.
was a clusterfuck. It was horrible because it has no concept of the idea that here's a drawing of an assembly, and that's not just a spreadsheet. You know what I mean?
Yep.
So it just
Yep.
scrambled my models completely. It had no idea how to keep things where they needed to be, where SolidWorks can find them. And so I've defaulted to doing pack and goes as I go along and save them. But the cloud, SolidWorks cloud backup for things, I'm not using it. We get it with the subscription, but
Yep.
there's still no easy way to just say, here, I want you to back up my assembly. Like I have one assembly, there's a big machine I've been working on for 5 years now. And I would use SolidWorks cloud service backup because I could also share it with people. Some of the other people are on the project, but when I go in and look at cloud services, how it's worked, it's really designed for enterprise use for big companies and not just for small teams. It just has so many buttons. Any advice on that?
Yeah. So that's a great question there. So I'll say two aspects of it. So one is that you're absolutely right in the sense that hey, your cloud data management and, and things on there, your cloud saving is that it was I guess it was really built for CAD. Where like, hey, a lot of your others, like yeah, OneDrive, Dropbox, Google Drive, or whatever. There, hey, it's built to store files online, but it's not built for CAD. So hey, especially your references and your things with that is that generally you'll have a lot of problems on there. Now, with that being said, is that it is a full blown data management solution as well. Now, the reason
Yeah,
why I say that is that you can use it just to store files, but the reason why you'll see so many clicks and so many potential buttons on there is that it has additional functionality that's in there. It's like, hey, let me do revision control. Let me go on different things here. So you have like you're saved up different revisions like as you're going along on there. So hey, right now I'm on revision C, but you could go back to revision A and so forth on there. So that's kind of part of the reason is why it's like, hey, kind of a little bit more I guess a little bit more work on that. But with that being said, hey, if you're able to learn or get used to some of the additional work on there, is at the end of the day, it does save time and make things quicker. Like for example, hey, if your files are saved there to the cloud data management, is that you basically, unless you're very intentional on there, but you basically never have broken references again on there too, of saying like, hey, this assembly is referencing these four parts. Oh, if you instantly move one of the parts to a different location or something changes on there, it's like, hey, I think everyone's had um the message like, hey, can't find part, can't find referenced on there. Can you really like to
right.
browse to it on there? And so when it's saved on there, now if you just use it to save on there, it actually ends up being pretty straightforward once it's set up. The main thing is just getting used to saving it in a different way and then how to find your files is really the two main things to get used to. So for example, I should have it loaded in. So if I take this one part right here that you have, is that over on my left or over on my right here, is that this is where I go into save it there to the cloud, save it to my cloud space on here. So I see right now this symbol is telling me, hey, it's not saved to the cloud. Right now it's just local, nothing on there. If that had a green check, then it would say, hey, it's saved to the cloud and it's up to date. So that'd be the first thing, is saying like, hey, when I save it or want to be backed up to the cloud, I just have to go over here and hit save from over there. That's really the first thing. So hey, if you know that and get to you works of workflow, that's half of it on there. So as soon as I hit save on this guy, it's going to, I guess, pull up a dialog that's going to go through on that. And let's see, I should be added in on this front on it here. But the other aspect to, I guess, be aware of is that since it's saving it there in the cloud, is that the main thing to get used to is that it's not a typical file explorer structure that you're maybe used to, where you have like, hey, all your regular folders and subfolders and stuff on there of what you're doing. Is that it is a data management. So that can take a second to get used to on this front. And this is taking, so something's going on with the machine as far as saving it here. But you have what's referred to as bookmarks, which is going to be basically the equivalent of folders, but you go in and with these bookmarks say, hey, let me save it to a location. So right now I am saving this to the cloud. I have like my space on the cloud that I've called JD, John Duffin Vault on here. But then I have this bookmarks, which is basically giving me, hey, which folder is it saved in on it there too. So once you save, hey, I go in and I can go into select bookmarks for what I'm doing, or I could go in and do like a recent one that I've done. So I'll go I'll go on here. Yeah, that's going slower in general, but let me just go to, this one. I'll save it, maybe my training space. So I save it here. And so now, hey, it's saved to the cloud at this point, and it's like kind of bookmarked from there. But the main aspect is, hey, when you're opening up these files, again, is I'm going to go ahead and pull up here on the web browser, is that you kind of have to know where to look for it. So you have like this insight on the web browser of where it's going. Now you can set this up so it's like, hey, really all that you see is the bookmarks. But I could go here, and then within the web browser, hey, I have my bookmark editor, which is basically saying, hey, here's my folder structure that I have. And so I look and I see, okay, here's all my folders that I just saved it to in this case. So, hey, I just saved that part to this folder over here, whatever folder you end up doing. So this is where you would go in and then kind of open it from. And so that's what takes getting used to, is like, hey, you are not opening from your typical file explorer like you would be used to. You're opening here, hey, from the web browser. So in this case, hey, I have this pulley part.
Yeah.
So I could, for example, hey, drag this into
Well, it looks like that all that is would be, I just think of it in terms of some place that has an IT guy who is the poor miserable soul. His job is to just keep all that stuff organized and instructions on how to use it and where everything needs to go, and that he has some obedient slaves doing the CAD work who will follow his directions. I'll just stick with my basic, C colon path, and I basically, all I have is one big directory for all the parts in the project, and then one big directory for all my commercial components. And then interesting about fasteners and Toolbox, I gave up on Toolbox. The interesting thing about Toolbox, about Toolbox and fasteners, right?
Yeah.
So the interesting thing about that to me was always that when you open up Toolbox, you'd have all these fasteners, and I was going like, why the hell do they have all these weird fasteners in it? And I realized after a while with my little handy machinery hands book here that somebody told somebody that was designing Toolbox, well, just go into the machinery handbook and model every part, every fastener out of the machinery handbook. So you have all these weird things that nobody's seen since the steam engine days
Yeah.
when they printed the, and it's like that's why all those fasteners are in there. But my model for bringing all the fasteners in is I get all my fasteners from Bolt Depot, which is great because they have fasteners. So I go into McMaster Car and I download the model of the fastener from SolidWorks, which is quick and easy and suppress the threads. And then I go to Bolt Depot and I get Bolt Depot's part number and I slap Bolt Depot's part number in it and stick it in my directory that's organized by, socket-headed cap screws in an 832 and then all the different lengths. So I can
Yeah.
find all my, and over time I've built this really nice library of fasteners where, I use everything from number 2 to maybe sometimes a half inch would be big. So I have all this library of fasteners, but anyway, I'm just kind of telling you that. I don't know
Yeah.
where y'all are at with Toolbox as far as it being um, integrating with someplace where you actually buy the parts. And nobody does that. McMaster does it, but McMaster only sells boxes of 100, and a lot of times you don't need a box of 100. So anyway, I'm just
Yeah.
rambling.
Yeah, no. It was a good point on there. And yeah, like I said, I mean, Toolbox, especially when it's set up right, can be really good. But like I said, hey, there's a bunch of random stuff. It's easy for you to put in bolts that are just random. Now, one thing I'll say is especially companies that are using bolts all the time and things on there and don't want to be putting in stuff that's there, so you can't customize your toolbox. Just saying like, hey, I have these parts on here of like I can still like quickly add them or do different aspects of them, but then you can have it say like, hey, remove these 7 or these so many so it doesn't show up in the list on there. And so that's one thing that I'll say. So you have like your toolbox settings on here that I'll open up, and it looks like that went up on the other screen. So let's see if I can pull that guy over. Yeah, there we go. So yeah, so customize. So I say, hey, customize my toolbox hardware. So hey, right now I have all these different standards. So I can say, hey,
Yeah.
as far as this toolbox goes, I want to. Oh, let me go back up there. I'm going to uncheck all these random ones. I only want ANSI metric or ANSI inch or whatever on here. Let's just first off just get rid of it. So, but I keep on unclicking. So you do it on here, and then you can do the same thing with any of these screws. So I can say, hey, let me uncheck any of these random ones that you wouldn't use or so forth on there or individual. So that's what I'd say is that sometimes for customizations, hey, let me just remove all those random stuff that you won't use. Let's not confuse them. Let's not make somebody put in a part that you don't need. So that's one thing that we'll see people do that are using on there. Just like, hey, let's just remove the non-applicable stuff. Like you said, it's like they took the machinery handbook and let's do all this stuff that nobody uses anymore.
Yeah. Yeah.
So
Well, the SimLogic was the company that created the toolbox, and SolidWorks bought it, and it's really very much still looks like the SimLogic product and works like the SimLogic product in a lot of ways, right?
yeah, so I mean, I guess I never used SimLogic directly on there, but I mean,
Okay.
it's similar similar for hey, you customize it, and then hey, then you can choose what you can bring in on there. I'll say the biggest time saver I'll see as far as toolbox comparatively on there, which I mean, at the end of the day, it's hey, whatever works for you. But hey, if you've used your whole wizard or your different whole series within SolidWorks, is that then after that, hey, if you use Smart Fasten or whatever on there, can kind of automate, bring in a bunch of hardware on there with like your stacks of saying, hey, my washer and my nuts, I can automate that instead of having to find each part, mating it up, go to my next bolt, mate it up, and so forth. On here, I can automate. So that's really the main time saver. By the end of the day, I mean, hey, it's a tool that's there. If it works for people, great. If it's easier to, like I said, hey, run over to McMaster Car or whatever, what you can buy, it's good. But like you said, I wish it could be nice for it to be integrated with something where you could buy that part directly of a one off screw. But
Right.
right now, at least as far as I'm aware, what's built in isn't integrated as far as that goes.
Have you heard of Bolt Depot before?
I've heard the name. I guess is it similar?
They're
Similar to
awesome because, well, they don't have models of their parts, but they
Yep.
have a really simple numbering system, and you can buy one, and so you take your bill of material, and if you have everything defined by the bolt depot part number, it's pretty easy to spit out an order for
Okay.
all these parts. So I use it for that because I don't know anywhere else. What they'll do is they'll ship you, if you go in there and you have a big assembly with a lot of fasteners in it, and you have
Yep.
like 10 half-inch 1032 socket head screws, they send that to you individually bagged, and they also will put the assembly number on it. So it's really a great way to
That's actually
order.
really
I've
nice.
always
Yeah.
built one-off. My whole career, I was building one-off pieces, for the most part, building one-off pieces of custom automation. And
Okay.
I always got my models from McMaster. McMaster has all their fasteners are nicely modeled, with threads, actual threads, and then you can suppress the threads and then just
Yep.
use the fastener that way. Um, but anyway,
Yeah, no, that's actually good to know. Yeah, because being able to buy one offs, like I said, for more
yeah.
custom jobs, or hey, we don't need a pack of 100, we need two on it there. So
So we're
that's really
coming to
really
the
good.
end of the time, and you're going to be sending me a video of this whole conversation.
Yep. So I'll send a video of it. Yeah, like I said, I started the recording probably about 10 minutes into. So I mean, I guess we talked about high level, but once we started looking at your model
Yep,
over on my screen, that's when I started
yep.
recording on there. So I'll send that
Okay.
over. I'll ask the salesperson just get the number on hey what the 3 months of sim is on there with it. So those are kind of the two main action items that I have over on my end there. But
Does
um,
MLC CAD sell in Germany?
we do not. We do not.
You do not. So if Martin wanted to buy it himself, um, anyway, we'll have to figure
Yeah.
that out as far
Yeah,
as
so if
how,
he wanted to buy himself, it would make the most sense for him to get it probably from a German reseller, and even from a sense of support of what you're doing on there. Hey,
right.
there's only a few hours overlap between Germany and here with it, and so hey, support wise, it might be a little bit more difficult as far as that goes
Do
with
you
it, but
still have any sort of open houses over there or sessions like the SolidWorks user group at MLC CAD Lawrenceville?
yeah, so we'll have different events that happen on there. So we've had a few I guess we've had several this year. Like hey, we had a tolerancing event on there, and then of course different training, or we had our new office open house and things with that. This let's see, I'm trying to think what's on the schedule for upcoming. There's like a data management one, but that's more on a deeper SolidWorks PDM, which is hey your
Yeah.
full blown data management system on there. But there are events that will happen with it. The user groups don't happen in our office. Actually, I'm not sure. I know pre-COVID they were holding them pretty strong, the user groups, but I feel like it's kind of gone silent for the user group leader, at
Yep.
least from what I
Yep.
sound like since then.
Right.
So I believe it might be the same, but I think the user groups might be um, yeah, might be less active now with
Okay,
it.
I just wondered. I remember I used to
Yep.
come pretty regular for what's new in SolidWorks and whatever sessions. But
Yeah.
anyway,
And I'll say usually we have I mean usually we'll have the once a year, hey, what's new, SolidWorks 2025 launch events and things on there, which we'll usually have on that front around this time. Or I guess yeah, this time or next year on here. However, this year, I mean, mainly I think since COVID, it's just been a lot less people coming, more people want to do virtually. They decided, hey, all the what's new events are going to just going to be
right.
virtual
Yep.
on there. So we will have some like, hey, some live virtual webinars and you should see some stuff. I believe on our website we'll have some like live online meetings on there, but not in the office. But you can definitely attend the online one for sure for hey, what's new and what's good on that front.
Well, I really appreciate this, John. This has been great. I'm looking forward to, I'm going to make a long list of all the things that I get screwed up and can't figure out. And for my 2 hour section for 2025, I'll probably schedule it earlier when
Hey,
that comes around.
Hey, that sounds perfect. It sounds perfect. Whatever works there, and we're here to help. And it's yeah, no, it's fun being able to kind of hear about what people are doing on a little bit deeper level and kind of talk
Right.
about these questions here. So
Yeah.
it's grand. But hey, absolutely get it scheduled, and we'll call it a good time.
So go to tendrilties.com, and it's not really ready for public release yet. It's TENDRILTIES, and
Let's see,
tendril
tendril,
tendril
TEN.
ties. It's with an L there, not an S. No, back up. Tendril, yeah, tendril now ties, TIES.com. See what happens on your machine. There you go. So that's the
Hey,
product I've been working on for 30 years. If you go to photos down there, you go to photos, uh, the next one
let's see.
over, the
Oh,
tab,
photos.
photos
There we go.
tab, and then there's a video there. There's a video right there that tells you how to use them. So I've
Okay,
been working on that for 30 years, and we finally got the machine going. That's been my big SolidWorks project for 5 years.
okay.
Um, so anyway, next time I see you, I'll give you a tendril tie.
Hey, absolutely. That'd be awesome. Okay, yep, wrap. Hey, that's cool. That's cool. And just having that pre-built wrap in so it's not um yeah, don't need to worry about any of your Velcro coming loose on there, just kind of in I guess more versatile on there. Actually, that's pretty sweet. That's pretty sweet.
So the little tail fastens to the cord, so it'll stay with the cord,
Stays
and
with
then
there. Okay.
that's what the little tail is for.
Hey, I like that.
Yeah. All right.
Awesome. Well, hey, thanks so much, Dave, on there. I'll send up some of those follow-ups on there too. But yeah, we'll call it a good time. I mean, I think with a fun Monday morning like that, I think we can just probably call it a day. I think we can go home for the day. I think
Yeah.
my manager
Well,
will be
I'm
okay with
actually gonna
that.
go
So it's just
jump on. I'm gonna go jump on my Veritrike and do 12 or 15 miles.
hey, there we go. There we go.
Yep.
Hey, that's awesome. That is awesome. Hey, well, awesome. Well, hey, great talking to you, Dave.
You
I'll
too,
talk to you.
John. I appreciate it. It's been great.
Hey, same here. Same here. Hey, enjoy the
Take
rest of your
care.
day.
Bye bye.
All right. Bye.